Okay, so if I gave you that problem, you should immediately look at that and you should say that's a hyperbola. Why is that a hyperbola? It has x squared and it has y squared. It's not enough that they're different. One of them has a negative. If this was a positive 9 and this was a positive 4, then it would be an ellipse. So it's not enough just to say the coefficients are different. You have to say one of them's positive and one of them's negative. All right, well, I want to know all of the information that we talk about with hyperbolas, which is the center, vertices, foci. There's no co-vertices, those are ellipses. The dotted lines, which are called asymptotes. All right, so that's all the information I want to know. Center, vertices, foci, asymptotes. What do you do? That's a plus 54x. Finish the square? Right idea, wrong words, it's called complete the square. Although finish the square sounds pretty good. All right, so to complete the square, I'm going to write 9x squared, and then I'm going to put the 54x next to that, and then the minus 4y squared and the plus 8y equals negative 41. So I put the x's next to each other, I put the y's next to each other, and the number goes to the other side. Absolutely. To complete the square on the x's, this number has to be a 1. It's not. To complete the square on the y's, that number has to be a 1. It's not. So you're right. We have to factor both of them. So what can I factor out of the x's? A 9. All right. So I'm going to factor out 9. And it, it will always conveniently just be a number here and you're going to factor out. The question is, will it conveniently be a nice number here or will it be an ugly fraction? For testing purposes, I'm pretty sure it'll be a nice number. So when I factor the 9 out, I get x squared plus 6x. So not only will it not be a fraction, if I'm really, really nice and generous, it should be that this number right here comes out to be even also. Why do you want this number to be even? Because in a minute we're going to have to divide by 2 and square it, and it's much easier if that's even. So I would expect that to happen on the final, that this number will come out to be even. All right, how about the y's? How about negative 4? Negative 4. When I factor out negative 4, what's left over? Good, you caught yourself. Y squared minus 2y equals negative 41. All right, what's the magic number for the x's? I take 6, I divide it by 2. 6 divided by 2 is 3, and then I have to square it. 9, so I put a plus 9 here. But not on the other side. What do I put on the other side? 81. Excellent. Why 81? Because it's really 9 times 9. So on the other side, I put a plus 81. Very good. That's a very easy mistake to make. How about the y's? What's the magic number? I take negative 2, I divide it by 2, that's negative 1. Negative 1 squared is 1. And I put a negative 4 on the other side. Excellent. Because this 1 is being multiplied by this negative 4, so it's really a negative 4. So absolutely, you take whatever number you put inside the bracket, you multiply it by whatever number's outside the bracket. That's what goes on the other side. Excellent. Okay, that gives us 9 times. How does x squared plus 6x plus 9 factor? X plus 3 squared. Minus 4 times y minus 1 squared equals 36. Very good. Okay, so now we've done the hard work. What's left to do? I can find the center, but there's something I really should do first. Why do you divide by 36? This needs to be a 1 over here on this side, so we should divide by 36. Divide by 36, divide by 36, divide by 36. This gives us x plus 3 squared. What's 9 divided by 36? It's 1/4, so I could just write it as a 4 down on bottom. And that's what we want anyway, don't we? We want the numbers on bottom like that. So that's why I would write it. Minus, we're going to have y minus 1 squared divided by 9, because 4 divided by 36 is 1/9, which means we have a 9 on bottom, equals 1. All right, now we have it written the way we need it. This hyperbola, is it going right or left, or is it going up and down? This one's right and left. Remember, for hyperbolas, these numbers really don't matter. What matters is which one's positive and which one's negative. The x is positive, which tells you it's right and left. For ellipses, it matters which number on bottom is bigger. For hyperbolas, that doesn't matter. Positive and negative is all that matters. All right. It's just a sign that tells you which way it opens. Yep. Ellipse, if this were a plus in the middle, if the bigger number is under the y, then the ellipse is tall, up and down. If the bigger number is under the x, then it's long, left and right. All right, so I think we can find all our stuff here. What's the center? -3, 1. And then vertices. Add something. I'm going to add to the x number because it's going left and right. So my y number is going to be the same, so I can fill my y numbers in. How much do I add and subtract to this x number? It has to do with that number right there, 2, because 2 squared is 4. So this is my a number. A is 2, b is 3. So since this is my a number and I'm moving left and right, I add 2 and I subtract 2. So -3 plus 2 is going to be a -1. And -3 minus 2 would be -5. For vertices, you always use a. And that's true for ellipses and it's true for hyperbolas.
So technically that's 2 squared, 3 squared on bottom.
Correct. So this is 2 squared on bottom and that's 3 squared on bottom. I took -3 and I subtracted 2. No. Nope. You only add the a. Well, actually, you add the a and you subtract the a. A always gives you the distance from the center to a vertex. So if I start at my center, I've got to go a to the right and I've got to go a to the left. B in an ellipse would give me my co-vertices up and down. For hyperbolas, B really doesn't tell you a whole lot. There's a lot to remember. I agree. Foci. What do I need to find the foci? I need the C number, which for hyperbolas is the Pythagorean theorem. So C squared is A squared plus B squared. So C squared is 4 plus 9. C is square root of 13. Again, I start at my center, and what am I going to do with the square root of 13? Because I'm moving left and right, I add it to the x's. How about -3 plus or minus? X is -3. So we would write these as -3 plus or minus square root of 13, comma 1. For a ellipse, it's a squared minus b squared. For a hyperbola, it's a squared plus b squared. And again, the good news is when you go to take your final, I'm going to give you a formula sheet with all these formulas. And I have it split. There's one section that says ellipses, and it has all the formulas for ellipses. And it says hyperbolas, and there's all the formulas for
We just have
hyperbolas.
to know, looking at the equation, if it's a hyperbola or an ellipse.
You have to know if it's a hyperbola or an ellipse, and then you're going to have to know how to complete the square.
Right, and then from there we look at your formula sheet.
And there you should be able to look at the formulas and figure it out.
Why do you have the C number to
That was the definition of C. If we draw our hyperbola, -3, 1 is here. Here's our center. And we had our foci here and here. Or, I'm sorry, our vertices. So the hyperbola is looking something like this. Where this distance from center to vertex was called A. And when we go to the foci, this distance we called C. And that's true for ellipses also. C is always the distance from the center to the focus. A is always the distance from the center to the vertex.
Just out of curiosity, how do you get the formulas throughout the year?
You mean like all those formulas we had in chapter 8, like those 170,000 formulas? Yes, I will give you the same formula sheet for that I gave you for that exam. Yeah. So you're actually going to get 2 formula sheets. You're going to get that formula sheet we had for chapter 8, and then you'll get another formula sheet for all this stuff in chapter 10. I think my formula sheet even has law of sines and law of cosines on it. I was in a really generous mood. I'm pretty sure those are on there too. Oh yeah. Oh, I gotta have it ready for Monday. No. It's like Christmas. You get to open it on Monday morning.
start crying. Yeah, every rat.
Every rat?
It's actually cool.
Put a bowl on it. All right. Asymptotes. We're almost done here. Our formula for asymptotes is y minus k equals plus or minus b over a times x minus h. Well, ellipses don't have asymptotes. If it went up and down, then it would be a over b. That would be the only difference. All right, so it looks like we're going to have y minus 1 equals plus or minus b over a, that's 3/2, times x plus 3. It's y minus, because the 1 is a positive. It's always a minus y minus k, so y minus 1. Okay? Questions? No. A is always under the one that's positive. And B is always under the one that's negative. So if the y had the plus in front of it, whatever number was under the y, that would be the A number. Other questions? For ellipses, A is always the bigger one. Other questions? Can we do an ellipse one? Sure. Let's do one with it's already all completed and stuff, so it's a little bit easier. How about we had x minus 2 squared divided by 16 plus y plus 3 squared over 25 equals 1. All right, once again, you should immediately recognize that that's an ellipse. Why do you immediately recognize it's an ellipse? I got x squared, I got y squared, I got a plus sign, and there's one more thing. The one that's closer. These two numbers are not the same. If this were a 25 and that were a 25, if those two numbers were the same, then it would really be a circle. A circle. Those two numbers have to be different. Because if these were both 25, I could multiply the whole equation by 25, and then it would be in the form of a circle. All right, so this is an ellipse because we got the squares, we got the plus, and these numbers are different. Is this ellipse long or is it tall? This one is tall. Why is this tall? Because the 25 is the bigger number, and 25 is under the y's. So what's your a number? A is 5 because a squared would be 25. So for this ellipse, a is 5, b is 4. For ellipses, a is always the bigger number. For hyperbolas, a is always the one that goes with the positive. Okay, good so far? Center. 2, -3. All right, so we said this ellipse is going to be tall. So when I go to find my vertices, am I changing my y's or changing my x's? I'm changing my y's because I'm going up and down. Y's go up and down. So when I go to find my vertices, it's going to be 2 comma something because I'm going up and down. I'm not changing the x's. Yes, if this were an x plus 2, then this would have a -2 here. If it were y minus 2, then I would have a plus 2 right there. And if this were an x plus 3, I'd have a -3 right there. Yeah, you always change the sign of whatever's inside of here. Because the formula has x minus h. The formula already has the minus built in. Okay, so to find my vertices, how much am I adding to my y's? More than 4. Less than 6. 5 sounds like a good number. Why 5? Because that's the a number. To find your vertices, you always work with the a number. And in this case, a is 5. So I'm going to start at -3 and I'm going to add 5. That puts me at 2. I'm going to start at -3 and subtract 5. That puts me at -8. So my vertices are 2 comma 2 and 2 comma -8. All right, let's do the foci next. Foci. Foci? That's bad. Foci. Am I going to be adding to my x values or adding to my y values? First I have to find C, that's true. Once I have C, am I going up and down or am I going left and right? I'm going up and down still, which means my y's. So my foci is going to be 2 comma -3 plus or minus something. And maybe it'll be a nice number to make. What's that?
No.
C squared is a squared minus b squared. And this is why, for this formula, a always has to be the bigger number. Because otherwise you get a negative here and then you couldn't do a square root. That's why a has to be the bigger number to match this formula. So c squared is 25 minus 16, which is 9. So this one comes out nice. C is 3. You were right. So you could write it that way. 2 comma -3 plus or minus 3. But normally when the numbers are very nice like that, we would split it. So typically I would write this as 2 comma -3 plus 3 is 0. And the other one would be 2 comma -3 minus 3 is -6.
So on a test, we're probably have this graph out.
Yep.
So versus use the a number, and foci use the number, right? Okay.
And what do I use the b number for?
co-vertices. The B number is for co-vertices.
All right, so let's start graphing. As long as I said I'm going to make you graph. And I think it helps to draw the graph as you're going to understand what's happening here. We've got our center at 2, -3. And so that's our center. And then our vertices were at 2, 2. And 2, -8. And our foci are here at 2, 0 and 2, -6. My ellipse is going to look like this. And you're right, there is one more thing I would ask you to find, and that would be the co-vertices, which are here and here. Yep. Like my ellipse? Sorry. On the test, I'll give you a nice grid so you can have nice accurate dots on your grid. Not sloppy like mine. All right, so to find my co-vertices, I need the B number. B is that distance from the center to the co-vertex. So to find the co-vertices, am I changing the x numbers or the y numbers? X. This one is x because this one goes left and right. So when you're dealing with ellipses, vertices and foci go the same direction. The only thing that's the other direction is the co-vertices. When you're dealing with hyperbolas, you don't need to worry about that because there's no co-vertices. Just have to remember that. So when you're dealing with ellipses, you're finding vertices and foci, and they go in the same direction. You will be given the formula for the asymptotes too. Yes, sir. It'll say find these things and draw me a nice little picture. All right, so my co-vertices, my y number is not going to change. And what's my b number? 4. So I start at 2 and I add 4, that's going to be 6. I start at 2, I subtract 4, -2. So my co-vertices are not drawn to scale. My co-vertices should have been over here at -2 and at 6. 11.5, yeah, we're skipping ahead to 11.5. The binomial theorem. If I asked you to take a plus b and square that binomial, what would you tell me the answer is? A squared plus 2ab plus b squared. That's correct. And how'd you get that? You do it so much after a while you memorize it. If you haven't memorized it, you do a plus b, and you FOIL it out, right? What if I asked you to do a plus b cubed? You're close. How would you do it if you didn't know the answer? But I already know if I take a plus b and FOIL it out, I get this, don't I? So I would take a squared plus 2ab plus b squared, and I would multiply it by a plus b. And what you would get, I'm not going to show my work, you would get a cubed, and then you would write, there's a 3, a squared b plus 3ab squared plus b cubed. Think there's a trick? Yes. Like if I ask you what a plus b to the 4th is? Alright, so what's the pattern? Well, first off, look at the exponents here. And what can you tell me about the exponents? Well, on the a's, a started with a big exponent, and the powers go down. On the other hand, what happens with the b's? We started with no b at all, and then what happened with the powers? They go up. Does this have to do with Pascal's triangle? It absolutely has to do with Pascal's triangle. What's Pascal's triangle?
Terrible trees.
Terrible what? What's Pascal's triangle?
Triangle of left.
It starts with a 1.
And then 1, 2, 1. And then 1, 3, 4.
What's the next row?
1, 4, 6, 12.
Okay, and how are you getting those numbers? It always starts with a 1, and then you do 1 plus 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then a 1 goes at the end. So notice this row, 1, 2, 1, 1, 2, 1. The next row had 1, 3, 3, 1, and in this formula we had a 1, a 3, a 3, and a 1. So if I asked you to do a plus b to the 4th, what is it? You're going to start with 1, 1a to the 4th. So it always starts with the a to the 4th. Plus, the next one's going to be 4. The power on the a goes down. The power on the b comes up. So 4a cubed b. Plus, the next one is a squared b squared. Again, the power on the a goes down, the power on the b goes up. Plus ab cubed. And then finally plus, not b cubed, b to the 4th. Power on the b goes up. When you start with the 4th power, your exponents always have to add up to a 4. So this one just has a to the 4, that's a 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4, and then a 4. So basically you start with a to the 4th, and then each time you go, your a's are going to get smaller. And then on each step, your b's simply get bigger. So that's a good question. So this one had power of 2, and then there were 3 terms, 1, 2, 3. This one had power of 3, we ended up with 4 terms. Power of 4, we ended up with 5 terms. That certainly seems to be correct. All right, so what if I asked you to take 2x plus 3y and raise it to the 4th power? What would you do? You're going to start with 2x. The whole thing is a. The whole thing needs to be raised to the 4th. So not only does the x get raised to the 4th, the number, the 2, is also raised to the 4th power. So that would be your first one. Plus, what's the next one? It's going to have a 4. 2x to what power? The 3rd. And then a 3y. And it's just 3y, isn't it? Because it's 3y to the 1st power. Okay. Plus, the next one has a 6. 2x squared. 3y also squared. Plus, the next one has a 4, a 2x to the power 1, 3y to the power 3, and then finally the last one, 3y to the 4th. All right, so final answer, what's 2 to the 4th? 16, so it's 16x to the 4th. Plus, you might want a calculator here. 2 cubed is? 2 cubed is 8. 8 times 3? 24 times 4. 96. X cubed y. Plus, the next one has 3 squared. 3 squared is 9. 2 squared is 4. 9 times 4. 36 times 6. 216, right? Hope somebody's checking me. Making up numbers here. See how it goes. Plus 3 cubed. 27 times 2. 54. 54 times 3. 162. Oh, crap. 54 times 4. 216. Why did I multiply by 2? I don't know. 216 xy cubed. And then the last one would be 81 y to the 4th. 3 to the 4th is 81. Questions?
Yeah.
What's the point of this? Oh, there is a point. Next semester, or in the summer, when you take Calc 1, you're going to learn about something called a derivative. And we're going to want to have a rule if we have a function to a power. We're going to want a rule for how do we take the derivative, whatever that means. In order to simplify this rule for the derivative, we're going to need to be able to simplify this. So how do I take x plus h inside a parenthesis and raise it to a power p? Well, if this p is like a 4, you don't want to have to FOIL it out 4 times, do you? It would be nice if I had a formula that told me quickly and easily how to do it. So that's the point behind it. This theorem is the key for probably one of the most important theorems in calculus. How do you take the derivative of something that looks like that, whatever a derivative is and whatever you use derivatives for? What's that? What do they use derivatives for? Take Calc 1. And you spend about 3/4 of Calc 1 studying derivatives. They're good for lots of stuff. But I don't want to give away the secret. It's a good time. Other questions? That's the whole section. You want to do another one?
Yeah.
Are you going to give us Pascal's triangle?
No, I will not give you Pascal's triangle. You should be able to develop Pascal's triangle. All right, so give me a number. 4x. Let's make it minus just to have some fun.
No.
Minus y to the 4.
I'll go ahead and 4.
I won't go higher than 4 on the final. Now, there is a way to get the numbers out front without having to write Pascal's triangle. So if I did give you a 19, there is actually a formula for the coefficients. And if you're interested in what that formula is, you can look in your book. They give it to you. But that's how you would do it. If this was power 19, you would not write down 19 rows of Pascal's triangle. That would take way too long. There is a formula for the numbers, but we don't need to know that. Okay, so I would take this 4x, and I would raise it to the 4th power. That would be my first term. Plus 4 times 4x cubed times negative y. That's right, since this is a minus, we're going to need minuses here. So it's times minus y. Plus, the next number was a 6. 4x squared negative y squared. plus 4x to the power 1, I don't need to write the number 1, minus y cubed. And then finally, negative y to the 4th. All right, and then I grab my calculator and I do 4 to the 4th. I'm at 256. X to the 4th. And then the next one's going to be a minus, isn't it? Because I've got this minus here with this y, so the next one's going to be a minus. Then I'm going to have 4 cubed times 4, that sounds like 256 again. X cubed y. Is the next one going to be a minus or a plus? Plus. Why is the next one a plus? Because negative y squared, negative times negative is positive. So the next one would be a plus. 4 squared is 16. 16 times 6, 96. X squared, y squared. And the next one is a plus or a minus? A minus, because a negative cubed is minus. 16xy cubed. And finally, plus y to the 4th. So having that minus in there didn't really cause many problems. It just meant we ended up with a couple minuses in our answer. Are there any like terms? So there's no combining. That's it. You leave it just like that when you're all done. Other questions? Should we have had more like this one? Yeah, always good to end with an easy one. Makes you feel good.